morning, guys. I hope you all are doing well for the preparation of your CAIEs. Guys, the topic today we are going to discuss is about the locus of a complex number. You know, the singular of is loci, we call this loci, and its plural is locus. By definition, the locus we can define definition of it is a path. It is a path traced out by a point as it moves by following a particular rule. By following a particular rule. And the rule is expressed as an inequality or an equation. Locus for complex number will be drawn on an argand diagram, and in we are well aware about the type of you know uh, the coordinate in the argand diagram. Guys, here I'm going to generalize the three types of locus. Three types of locus we know are going to be discussed as a part of our syllabus, that is for A levels. Number one, that if you have like z minus a equal to some constant, and we will read this as distance of z, a complex number, from a point A is a constant, that a constant is r. Whenever the scenario is like this, this is the case study, whenever you see z minus some point equal to or with inequality, it can be with inequality as well. I told you it can be a rule that expresses inequality or an equation. So it can be z minus a is less than or it can be, here I'm going to write z minus a less than or equal to or is a constant. So it means whenever you have this condition, then you need to know the distance of z. Suppose z is somewhere and this is constant point A, and z is like a circle whose center is A. So z can be a point, can exist on the circumference of a circle. Anyway, these dotted lines This is z because it is a constant distance from A. So constant distance is r. R is called the radius, and A will be the center of the circle. So whenever you will see the modulus of z minus A is equal to some constant, then it means you need the locus will be on a circle. Locus will be a circle. And now in order to shading will be done laterally. Just fix this thing, that what kind of shape you can extract it out once you have this kind of locus. Second, I can say second point, number 2, if you have argument of z from a point A equal to some angle, say theta. Argument mean angle, and theta is will be given to you. So you need to draw a half line. We call this rule half line rule. Half line, half lines, and part lines. We name this. This is circle. This is, and how can we draw this? Yani, you need to mark the position of A on the Argand diagram. Suppose we have this one, Argand diagram, and same here it must be, because you are drawing the locus, so it must be Argand diagram. And Argand diagram, on the x-axis we have real of z, and on the y-axis we have imaginary part of z. This is the point of intersection. Same like here, this imaginary part of z, it's a real of z. Okay, and from point A, and how you will read this one, the case study, we will read it as the argument of z from A is this, is theta. It can be in degree, or it can be, angle can be in degree, or it can be in radian. So from here we can say from point A to a certain, here suppose z is here at this line is z. So the other arm of this will be a line that must be parallel to the real axis like this, and that form angle theta. For example, if you say argument of z minus 2 plus 3i, okay, 2 minus 3i equal to say 30 degree. Then what it means, if you compare this one with the rule, that it must be written like this: argument of z, take minus common, because here z minus a, for the point take minus, it will be 2 plus 3i is equal to 30 degree. So here, if you can compare this result with the rule, here a fixed point A is 2 plus 3 iota, and in term of coordinate point we can write it as 2 comma 3, and theta is what, 30 degree. So on an Argand diagram, we can draw the locus of this is real of z and imaginary of z. 0, say 2, x is 2 and y is 3. Suppose it is here, a point is lying here, 2 comma 3, and this is what z. Z can be anywhere, here, anywhere, at this line it can be anywhere. same here, and this is Z, and the line parallel to the real axis, that is this way, and this must be an angle theta must be here 30 degree, right? I hope it is clear, because you guys need to be very strict about this concept, that the here the first rule, z minus is must be a minus, then a point should be a constant, z minus a point or is less than bigger than z minus. It means always you need to write the point that must be subtracted from z. Similarly, here argument of z minus a. So that's why in this example you can't take 2. If you take 2 as a 2 point as 2 comma minus 3, it will be wrong, because first you need to take the common minus and then you can mark out the point, exact coordinate of the point. This is the second kind of locus, and third kind of locus is here, that can be represented by, I'm going to write it here. Third kind is that z minus point A, the distance of z from A should equal to or less than or equal to z minus B. Whenever you have a two complex number like this in contrast of each other, that are equating each other or less than or equal to, then it means you are talking about the perpendicular bisector. Case is called perpendicular bisector. This is the third kind of locus, bisector. How? We will read this as the distance of z from a certain point A is equal to distance of z from another point B. Suppose A and B are here, and we will join A, B with each other with a straight line, and here we need to draw the perpendicular bisector, because this is case study is called perpendicular bisector of AB. Bisector of AB. So for the perpendicular bisector, we need you to find the midpoint of A and B, the point A and B, the perpendicular bisector of A and B. Midpoint of A, M is the, we can say, the midpoint of AB. Suppose it's here. We draw a line like this, right? And M is here. This stand mean, M stand mean this is MB or AM is the same, because it's a line bisector AB at point M. And as Z is lying anywhere over this perpendicular bisector line, it can be anywhere at this line. Suppose Z is here. So it means if you join A with Z, it will be same as B with Z. So this distance must equal to this distance. Or it can be if Z is here, you can even say distance of A from Z will be same as B from Z if Z is here. Got it? That means you will draw perpendicular bisector. Same here. This one, if Z is here, bottom will be same. So this is a case study. Only 3 cases of locus we know. That is number 1. Whenever you have the locus, here I can say types of locus. Number 1, when you have z minus a is equal to r or any other within other inequality, we can say that it is the distance of z from a fixed point A is a constant. That means the shape of locus will be a circular shape. as you can see here. But if your argument of z minus a is equal to theta, so it means the angle you will form, that is called half line or part line, right? And we call this half line because if you proceed this here, because you can see here, if you can proceed this line and you want to get the angle bigger than this, like this, it will not be true for the theta, it will be bigger than theta. Or if you go with the here even clockwise, even then it will be more than theta. So it means that conditions falsify the given angle. So that's why we call this a half line. Only in short, we need to take the start of the line from the point which is going to be subtracted from z. Here it is a, right? So this will be the angle. And third case study is when you have the two modulus of two complex number equating each other. So then it mean that you are talking about a line bisect. They are fixed from they are away from a certain point. We can read it as z minus a mean distance of z from point A equal to distance of z from B. So it means you have to talk about a perpendicular bisector of line AB. Say take example of these one by one with other inequalities as well, and we have to shade it. In short term, we can say shade the loci with a certain condition. Condition is like I will toss up different things. Is z plus 2 minus 3i modulus less than r. R means was 1. Okay. Here you can see 1 z minus. This is one side of modulus and other side is we have a constant number. So it means this case study can represent the case 1 of the locus, that is about circle. But for that we need to make z minus something, the constant number. So z minus, so these number can be written as minus 2 plus 3 iota, because this is minus for by default and this is becomes a fixed point and it's less than 1. So now you can compare this, the first condition as z minus a less than r, the first case study. So here a, that will be the center of the circle, will be minus 2 and 3 having coordinate this, and radius is 1. So on an Argand diagram, Argand diagram, we can show this. Okay, let me draw the clear one. This is the real of positive real of z, this is the imaginary of z. Here I can say negative of real. So suppose minus 2 minus 0, here 1, here I said 2 minus 2, and here 1, 2, 3, 4, 5. Okay, same here in the dot bottom, minus 1, minus 2, minus 3. Guys, one very important point you need to keep in mind, the space, the selection of the space in along x-axis and y-axis must be same. This space must equal to this space and this space. In order to draw the accurate shape, you must keep the same scale on both axes, vertical and horizontal axis. You must keep the same scale. Okay, the first 2 and 3, minus 2 and 1 to 3, it will be here. The center of the circle will be minus 2, 3, a. As it is having a radius 1, so we will move 1 point towards right of it, it becomes here 1 point towards left of it, it will be minus 3 here. So I can say here 1 point down here, 1 point top here. So it will be a like this circle, right? It will be a circle like this. Okay, let's make it more precise and clear. Yes, it will be sorry, it will be circle like this. Okay, yes, here and here. As it is very much clear, the radius is less than 1. So in order to justify this inequality, we will not draw the circumference with the bold. I will give it a dotted. Yes, like this, because only it has single inequality, not having equality. So it will be like this. I will show this a dotted line, and the shading part will be only that will be inside the circle, because the distance of z from here it is, this is A center and this is R, and R is smaller than 1. In distance of z from A is less than 1. So the circumference will not be the part of this shade, only you will shade the inside of the circle, except the outer boundary circumference. I hope it is clear. Take another example. The most important part of this case is to find the center. How can we find the center? By keeping minus in between z and the point, fixed point. Say we have another question like z modulus, say modulus is less than equal to 3. What to do? Here we have only z modulus, distance of z. We don't have a fixed point. So I can write it as per rule, it must be a minus with some point. Z minus, I can write 0 plus 0 I can assume the fixed point is origin, because it is nothing, it will be origin less than equal to 3. So here center of circle will be origin 0 0 and radius is what, 3. Let's see how to plot it on an Argand diagram. Same like you will draw this. This is real of z. This is the imaginary of z. 0 0 is here, right? This is 0 0. As radius is 3, it means you have to go 1 2 3 unit towards right of this fixed center point, and 3 unit towards left of this center point, 3 unit above, and 1 2 and 3 down. So if you join this, we will get a circle like this, right? I hope it is clear. Now we have to shade. We will shade, it is less than or equal to 3. So we will shade all the part including the circumference but inside it. I hope it is clear, right? Take another example. Suppose we have question like this. Z minus you can say 2I is less than equal to 1, or instead of, if you put it greater than equal to 1, so it means You need to write it first in from the center. What comes the center? It will be z minus 0 plus 2i. If you open the bracket, you will get this back. Original question greater than or equal to 1. Here the center is meaning a fixed point is 0 comma 2 and radius is what? 1. So on an eigen diagram, let's see how to plot and how to shade this. This is real of z. This is imaginary of z. 0 says 1, 2 is 3, 4. Okay. So center is 0, 2. 0, 2. Center is here. And radius 1. So it is 1 point here, 1 point down, 1 point top, 1 point left. So I will draw the circle shape like this. Okay. I hope it is clear. Now the shading area is bigger than or equal to 1 in radius. So here we will shade the area out of this circle. And out of the circle, this is the whole world. You can shade how much you want. Anywhere outside. Here. All the area will be shaded. But not inside of the circle. This is the condition of the question. I hope you understood. Right? We can't go inside because it is the different distance of z from this certain point center is greater than or equal to 1. So from greater than 1, the center radius is 1, so it will be more than. So we will shade outer word. I hope it is clear. Similarly, guys, now take few examples quickly for the arguments. Rule number 2 for the locus, second locus. Here, any example of argument is D. Shade any argument of z minus say 2 minus 3i is less than pi by 4. For example, this is a case where we have to shade this. So in an eigen diagram, we will plot this. It's a real of z. You guess, well, it's imaginary of z. So it's a half lines. So we first write this in proper format to make minus with the z minus. If I take minus comma, it will be 2 plus 3i is equal to pi by 4. So it means the fixed point of the angle from which you need to start, that is 2 comma 3. So say 2 comma 3 the post positive here. This is a. And theta is what? Pi by 4. So from a to z, you will draw a line from this fixed point. Say z is here somewhere at this line. And the next you need to draw a line parallel to the real axis, such a way that the angle between this line and this line must be pi by 4. Now question says, and your z is lying anywhere at this blue line, right? Z can be anywhere because angle will remain same. Now the question says argument of z minus a fixed point is less than pi by 4. So less than pi by 4 mean only less than, so blue line will be not the part of your shading, only inside it. You will shade this on area only, right? Because if it is greater than, then you will go outside of the blue line, upward. Fine. I hope it is clear. So take a one more example for this. Most probably the students sometimes they stuck it. If argument of z Okay, make the same point minus 2 comma minus 3i is you can say less than 3 pi by 4. 3 pi by 4. Then he comes to be 135 in degrees if you want. So let's start how to draw it. First argument of z minus 2 plus 3i. Reshape the statement in the proper order to get fixed point A, that is 2 comma 3, and theta is here 3 pi by 4. First we will draw this. This is the, you know, this is the real axis and this is the measuring axis of z. 2 3 suppose here, A is here, and from a line parallel to the real axis is here, right? This is parallel to the real axis, and we need to make a line that makes angle 3 pi by 4. So it will be around here, more than 90. And suppose this is what, 3 pi by 4. And we need to shade, we need to shade the area that is smaller than 3 pi by 4, because till from this point to this point it is 3 pi by 4 anti-clockwise. So shading area will be all this. Below this black line will not be the part of your solution, less than black line. This all area will be the shading part. I hope it is clear. Okay, so locus 3 we will discuss in our next video, because already it's for 30 minutes. I hope it is clear. Good luck. See you in the next video. Bye.